Bacteria love moist surfaces. Once they have settled there, they do not live as solitary organisms but form larger communities that are embedded in a protective film. These biofilms are found on various surfaces, for example at home on light switches, in the bathroom, on toys or keyboards, on shopping carts or ATMs that many people touch with their hands. This can lead to contact infections. The bacteria, such as the pathogenic bacterium Pseudomonas aeruginosa, are often persistent and defy the body's own immune system or chemical biocides. Current research approaches are therefore trying to prevent bacterial colonization of material surfaces or at least to make it more difficult. A team from Johannes Gutenberg University Mainz, JGU, and the German Federal Institute of Hydrology, BFG, in Koblenz has now developed a new approach using ceria nanoparticles. Communication proceeds nonverbally with the help of signaling molecules that are continuously emitted to the environment, whereby different languages and dialects can occur depending on the specific bacterium. As bacterial concentration increases, so does the concentration of the signaling molecules. This allows bacteria to detect the number of other bacteria in their environment and activate processes that enable the formation of biofilms. This interference in bacterial gene regulation is also of pharmacological interest, because pathogenic bacteria can evade the attack of the immune defense or the effect of antibiotics by forming biofilms. The cooperation partners from Mainz and Koblenz demonstrate the enzyme analog catalytic participation of the CEO2 nanoparticles via an analysis of the reaction cascade at the molecular level. This shows that the CEO2 nanoparticles interfere with biological processes just like native enzymes by modifying and inactivating signaling molecules. Antibacterial surfaces without the risk of resistance formation made possible. Cerium dioxide is non-toxic, chemically very stable, and it is contained, for example, in modern vehicle exhaust catalytic converters, stated Dr. Eva Putz, who carried out her doctoral thesis on this project. She is convinced that cerium dioxide is a viable and cost-effective alternative to conventional biocides. One practical application of our findings is to block bacterial growth and prevent bacterial infections, she said. Most importantly, it works not only in the lab, but also in everyday use, emphasized Nils Kelsch, who performed the biological trace analysis in his doctoral thesis. The danger in combating biofilms with biocides and antibiotics is the formation of resistance. However, this could be effectively circumvented in an environmentally friendly way by coating polymers with CEO2 nanoparticles. Make a difference. Sponsored opportunity story source. Materials provided by Johannes Gutenberg University Mainz. Note: content may be edited for style and length. Communication breakdown. Into the molecular mechanism of biofilm inhibition by CEO2 nanocrystal enzyme mimics and how it can be exploited. Ax Nano. 2022. 16, 10, 16091 doi. 10. 1021, ACS Nano. 2CO4377 Cite this page. Johannes Gutenberg University Mainz. Inspired by nature. Silencing bacteria. Cerium dioxide nanoparticles work in biological processes like natural enzymes and change signaling molecules, thereby preventing the formation of biofilms. Science Daily. Science Daily, the 28th of October 2022. ift.tt/xbbd6wg. Johannes Gutenberg University Mainz. 2022, October 28. Inspired by nature. Silencing bacteria. cerium dioxide nanoparticles work in biological processes like natural enzymes and change signaling molecules, thereby preventing the formation of biofilms. Science Daily. Retrieved October 31, 2022 from ift.tt/xbbd6wg Johannes Gutenberg Universität Mainz. Inspired by nature. Silencing bacteria. Cerium dioxide nanoparticles work in biological processes like natural enzymes and change signaling molecules, thereby preventing the formation of biofilms. Science Daily. https://ift.tt/xbbd6wg. Accessed October 31, 2022. Thanks for watching. Please subscribe my channel for more videos.